Hey everyone, and welcome. So glad you're joining us today. If you've ever stared at a massive tangle of electronic wires and just felt completely overwhelmed, well, you are definitely in the right place. In today's explainer, we're going to completely demystify the magic of audio electronics. We're taking a custom DIY Bluetooth MP3 player circuit diagram, which, yeah, looks pretty complex, and breaking it down into a super simple logical journey. By the end of this, you won't just see random wires and chips. You're going to understand exactly how electricity transforms into your absolute favorite music.
Okay, let's dive into this. Here is our complete blueprint for the ultimate DIY Bluetooth setup. Now, I know, at first glance, this kind of looks like a colorful spaghetti of wires connecting a bunch of intimidating black boxes. But seriously, don't sweat it. We're going to conquer this whole diagram together. Instead of trying to take it all in at once, we're literally going to follow the journey of the electrical signal. We'll trace how power enters the system, how the audio is actually born, how it gets supercharged, and finally, how it makes its way out to your ears.
So here's our roadmap for today. 1. The complete DIY audio blueprint. 2. Powering up the system. 3. Routing the audio signal. 4. Amplifying the sound. And 5. Connecting the speakers. It's a structure that's really going to turn this static image into a dynamic, step-by-step story of how power becomes sound.
All right, let's jump straight into section 1, the complete DIY audio blueprint.
We'll kick things off with a quick hardware check.
So what are we actually working with here? This is our complete hardware inventory. At the very top, we've got the brain of our operation, the MP3 Bluetooth Module. Below that, sitting right in the center, is our TDA2822A Amplifier chip. That's our muscle. Down at the bottom is our power source, just a standard 5V adapter. Then we have our electrical filters. We've got two smaller 16-volt 100 microfarad capacitors up top and two much larger 16-volt 1000 microfarad capacitors near the bottom. And of course, flanking the sides are two audio speakers just waiting to make some noise.
We're going to tackle this wiring process in 4 clear phases. Phase 1 is power flow, Phase 2 is signal routing, Phase 3 is amplification, and Phase 4 is speaker output. Basically tracing that electrical current from the wall adapter straight to your ears.
Moving right along to section 2, powering up the system. This right here is the pulse. Direct your attention to the 5V adapter down at the very bottom. Notice how the power splits right away. The bright red wire, our positive charge, travels up and literally branches off. It feeds directly into the amplifier chip in the center, and it also reaches way up to the right side of the MP3 module to power its display. But power needs a complete circuit to actually flow, right? That's where that thick black wire comes in. That is our ground wire, and it acts as the vital return path for the whole electrical ecosystem, connecting the adapter to the amp, the module, and eventually the speakers.
Actually, quick side note here, and trust me, anyone who has ever dabbled in electronics has learned this the hard way. Mixing up your positive red and negative black terminals is hands down the absolute easiest way to build a completely silent speaker. Or, a smoky one. That's exactly why following that black ground routing so carefully throughout the diagram is absolutely crucial. Always, always respect the polarity.
All right, with the power flowing safely, we arrive at section 3, routing the audio signal. We're moving up to the brain.
Now, what's really interesting about this slide is right here at the bottom edge of the MP3 Bluetooth module. Once your phone connects and sends a song, the module processes it and outputs it as this tiny, super fragile electrical signal. Look at those 3 connections, R, G, and L. The green wire carries the right audio channel, the yellow wire carries the left audio channel, and smack in the middle is the black ground wire. This is the exact moment our audio journey officially kicks off.
But before those delicate left and right signals can hit the amp, they have to pass through our first set of capacitors. Look at the contrast here. For these initial input signals, we're using the smaller 16-volt 100 microfarad capacitors. Why? Well, they basically act as filters, smoothing out any unwanted raw, flat power, which we call DC voltage, so the audio stays pure. Later on, we're going to use those massive 16-volt 1000 microfarad capacitors for the final output. That's because pushing a huge amplified signal just requires a lot more electrical buffering. It's all about matching the component to the job.
Which brings us to the really fun part. Section 4, amplifying the sound. We've reached the muscle. Let's talk about the absolute star of the show, the TDA2822A chip. This little black square is our central amplifier hub. See, the audio signal coming out of the MP3 module is way too weak to physically move a speaker cone.
If you hook the module directly to the speakers, you'd barely hear a whisper. The TDA2822A takes those small, weak audio signals, combines them with the raw power from our 5V adapter, and churns out powerful, loud electrical signals capable of actually moving air. That is exactly why all the wires converge right here in the center. So the crucial point is exactly how these inputs are wired into that chip. Follow the yellow and green signal wires with me. You can see them pass through the positive ends of our small 100 microfarad capacitors, exit the negative ends, and plug right into pins 6 and 7 on the top side of the amp chip. Meanwhile, our black ground wire comes down from the module, splits, and securely connects to pins 5 and 8. Now the amplifier has everything it needs: audio instructions and a totally grounded circuit. It is ready to do the heavy lifting. And now for the grand finale. Section 5, connecting the speakers. This is the voice. Track the flow with me now on the bottom side of the TDA2822A chip. The newly amplified super high-energy sound literally bursts out of pins 1 and 3. Look at those bright blue wires carrying that heavy load. But wait, they don't go straight to the speakers. First, they have to pass through the massive 16-volt, 1,000 microfarad capacitors. These big guys act like giant shock absorbers. They block any stray DC voltage from completely frying our speakers, ensuring that only the beautifully amplified, moving waves of music make it through. And this brilliantly illustrates the final step as we close the loop. Trace those final blue wires out of the large capacitors. They connect perfectly to the positive, red-marked terminals on both the left and right speakers. But remember, no circuit is complete without a ground. Look at the black ground wire making its final run, branching off to connect to the negative terminals of both speakers. The loop is officially closed. The electricity has successfully pushed the speaker cones, vibrated the air, and created music. We actually did it!
So we've taken what looked like a completely chaotic jumble of wires and revealed the really elegant, logical story underneath. You now understand exactly how power, signal, amplification, and output all intertwine perfectly. You have the blueprint. You have the knowledge. So the only question left is, now that you have the blueprint, what tracks are you going to blast first on your custom build? Think about it, get building, and keep learning. Thanks so much for hanging out with me for this explainer, and I will catch you next time.